Hi there, and welcome to Context Free, where we talk about programming languages. Today, I'm excited to welcome guest Oscar Spencer, co-author of the Grain programming language. Grain is sort of like ReasonML or ReScript, if you've heard of those, but focused on WebAssembly. They're sort of like OCaml, but with sort of a JavaScript syntax. And as usual before one of my interviews, let's take a look at some code samples, starting with a basic hello world. And while there are binaries you can download for Grain, they tend to compile a bit slowly, so I recommend using a container image for now. They might be improving this in the upcoming 0.5 release. So first, let's run a hello world. And it does what we expect, but that's not so interesting. Let's take a look at a much more elaborate example, though just in brief. This is the same fake web scraping that I did in my recent monad and error handling videos. So you can go and compare this with other languages by going back there. Anyway, I've imported some modules here, which I can use as namespaces to have access to functionality. I've also developed a little bit of a data model here with these records with optional strings that capture and or summarize information from supposed web documents. Grain also has a result type, which you might recognize from something like Rust or OCaml. I can concatenate strings, and I can build objects whose type is inferred. I can also handle my optional types or my potential errors. And note that I have a shorthand property syntax, like in JavaScript. This is also called field punning in some languages. It's sort of as if I'd said title colon title right here. Meanwhile, then I can loop through these fake URLs and print out what I read. Let's take a look at it. And without going into details, these are the results I'm expecting. And here I've chosen to be explicit with my function types, but I've left them out in my next example, which is a color converter. I've made three-dimensional points as tuples, and then for each color I have an option. I can choose whether I want to use HSV, RGB, or a named color. And here I've built a map of named colors, where this right angle is the syntax for an array as opposed to a linked list in Grain. And here's my converter from HSV to RGB. Note that I can destructure tuples. I could also destructure named values if I were using them. Pattern matching also works. And here I have a list of colors, RGB, named, HSV, or unrecognized, to see what happens when I convert them. I've also made an HSV of strings, just to see what happens. Let's run this. And here I have my conversions. The RGB just goes straight across. The yellow looks up its value. And for the HSV, I purposely used rational numbers, aka fractions, just to prove that these work in Grain as well. This is not always out of the box in many languages, and we'll discuss numbers later during the interview. Now for this HSV of strings, my type parameter, I'm just call a scalar. It's a tuple of 3 of the same thing. So I can make an HSV of anything. However, if I want to use HSV to RGB, the compiler will infer that I have to have numbers here. So I try that conversion. I get an error on line 58, which is what we expect. Meanwhile, back to working. I also want to see the sizes of these WebAssembly modules. Short for WebAssembly is Wasm. Anyway, so my hello world is 58K, which is a bit on the high side for something like, say, the Wasm for Fantasy Console. And once we've incorporated other capabilities from other modules, we're up above 100K in size. Since Grain is such a high-level language, I think it'd be really cool to get support for it to get even smaller. Maybe that's something that can happen in the future. Meanwhile, just to prove that these Wasm binaries are portable across Wasm runtimes, let's use the Wasm 3 engine to run the HSV example. And we see it works just fine here as well. Wasm 3 is a fun WebAssembly interpreter. Anyway, hope this has given a bit of a flavor for the language, so let's get on to the interview, which I've edited and added my own visuals to in the background as usual. Let's get started. So to start with, could you please introduce yourself?
Yes, my name is Oscar Spencer, and I'm one of the co-authors of the Grain programming language.
And how did Grain get started?
Grain got started, funny enough, as actually the final project of a grad level compilers course, where throughout the course we had built this toy language, and that was a load of fun. And for the final project, you got to choose, hey, add some interesting feature to the language. And at the time, WebAssembly had just got turned on by default in all the major browsers. So I was super hype on WebAssembly, and I said, you know what, a really cool feature would be is if we scrap this whole x86 thing and just made it compile to WebAssembly. And our professor was like, sure, go for it. I don't care. And that essentially was how the language was born. And we just, never looked back after that.
Awesome. So you definitely do emphasize WebAssembly on the website for Grain.
Mhm.
What benefits does WebAssembly give, or why do you focus on it so much?
Fundamentally, the answer to that is just I believe WebAssembly is the future. There's so much we can do with WebAssembly from its application model. And I sort of hate to put it this way, but I think it's the way that makes folks really understand the point of WebAssembly. It's sort of everything the JVM wanted to be. So it's this model where it's, secure by default. We've got sandboxing on, so you're already controlling everything that's going on, that's happening with computation in terms of like executing WebAssembly programs. It can actually run anywhere once you compile it. So like once it's compiled, you're done. It's going to run in any Wasm compliant runtime, right? We're actually seeing use of WebAssembly as replacing containers, where one of the biggest hurts that people have right now with containers is that they're huge and they're a little clunky to get in places, versus WebAssembly modules are nice, small, and you can actually do that one thing and then go away. So I think WebAssembly is actually going to be the future of how we do a lot of computing, both inside the browser and outside the browser.
Yeah, awesome. So are you more concerned with the client or the server, or both?
Yeah, absolutely. It's funny because in the early days of WebAssembly, I certainly thought that, this was going to be the JavaScript killer. That's what WebAssembly was going to be. Everyone wanted to get, their favorite languages running in the browser. And I thought that's a lot of what WebAssembly, was going to tend towards. But over the past few years, we've actually seen a really interesting shift where most of the WebAssembly computing that's happening these days is on the server side. We're not actually seeing a ton, happening in the browser. And that's actually for a pretty good reason. It's that over the years, JavaScript runtimes have gotten really freaking good. And there is actually not a ton of performance gain to be had by just writing your entire application in WebAssembly, from like the browser side of things. So sort of with that in mind, people have seen like, what, actually, doing the sandboxing thing, these small binary sizes, if we can do this on the server, we can unlock a lot of interesting things. Like we've seen a lot with edge computing, for example, of like pushing compute directly, out close to your users. That sort of thing. So certainly with Grain, we've been focused a lot on, doing things on the server side, since that's, what folks have been doing. But of course, lots and lots of people are asking, hey, like I want to get in the browser. I want to start, using the DOM. I want to do, a lot of things like this. And, we'll certainly be getting back on track to the browser in due time. That's for sure.
Okay, cool. So in terms of WebAssembly as your currently only and maybe always primary target,
Mhm.
does that influence your language design at all?
Yeah, absolutely. We want to be very close to WebAssembly. One of the things that we've sort of seen so far with programming languages that have, started to actually compile to WebAssembly is that a lot of them weren't necessarily built with the idea of WebAssembly in mind. A lot of them were certainly built like, hey, this thing's going to just run as a binary on some server, whatever. We're going to link in all these libraries, things like that. So some languages, and actually, I think a really great example of this is Swift, where if you compile a Swift program, you get all of Swift's runtime in that one Wasm module. So you get these Wasm modules, and this is going to sound crazy when I say it, but a meg or 2 meg, Wasm, binaries. And depending on the context, that might actually be too big, compared to, some of the modules you see coming out of, Grain or Assembly Script that are like these 50K modules, right? So in terms of like the language design, we want to make sure that, with Grain, you can actually use all the features of WebAssembly that, are reported. So when folks say, hey, you want to be able to bind to these host runtimes and things like that, we want to make sure that sort of stuff is super easy in Grain. So it's not supposed to feel super convoluted, or you have to go out of your way to make these things sort of work. It's that, hey, I'm using this. It actually feels like a language that was designed and, thought around WebAssembly. When I want to do something like use reference types in WebAssembly, that's something that we want people to feel like, hey, actually, they thought about this when they implemented it. It's not just something that's going through LLVM and eventually landing as a WebAssembly module.
Okay, cool. Awesome. Now, Grain is implemented in Reason, which is sort of a variant of OCaml, right?
Mhm.
Uh, and Grain and Reason seem to have some similar goals in terms of making sort of that OCaml thing more maybe approachable to people from other mainstream languages, whether JavaScript or otherwise. But what are the key differences between Grain and Reason and ReScript or other such efforts?
Yeah, absolutely. So with languages like, Reason, ReScript, and Grain, we're all sort of kind of doing a similar thing in the sense of OCaml fundamentally is an incredible language. And, we want OCaml to be a language that everyone absolutely adores and everyone uses. Like we all believe in it. We believe it is this industrial strength language that you can use to build all sorts of applications, in a safe way and a maintainable way. But unfortunately, it's just not super approachable for folks. You see a lot of people like they feel like when you show them their first OCaml program that you sat them down for a math lesson, and that's super scary for folks, right? Like the first idea, with Reason and ReScript is like, hey, let's actually go ahead and just take the syntax. Let's get that out of the way. Let's not make people feel like that. Let's make it look a little more C-like, a little more like JavaScript, so people actually feel a little bit comfortable. And then let's start actually introducing these concepts, of like having the super strong type system, having pattern matching, things like that. And once you start introducing that to folks, they say, oh, wow, this is actually fantastic. And actually, the compiler is my best friend. And this sort of the exact same thing with Grain. For us, there were a couple things with OCaml that we think still, hey, yeah, like just not having nice mutability for like certain like local variables and things like that can be a little bit of a struggle for a lot of people, because when you've been thinking about it a long time of writing programs in a very functional way, it's very natural. But for a lot of folks just coming from, say, JavaScript, it's not your first thought. So just adding in a couple of extra features like this that make people feel a little bit more comfortable, but slowly nudging them towards the more and more functional concepts, folks tend to love it. They say, oh wow, I actually had a great time writing this, like the compiler was my friend like in this situation. And that gets people really excited. And so, yeah, I mean, that's a lot of what we're trying to do. So very similar concepts to, those languages, but, with WebAssembly as our major goal. Because right now for WebAssembly, a lot of the languages that folks are using are super duper low level. People are writing C, people are writing Rust, people are writing Go, and these languages are all fantastic. But I think for a lot of people, a super high level language, like something like Grain, something more like a Python or a JavaScript is what is going to bring a lot more people into WebAssembly and get a lot more eyes on it and just keep advancing the technology.
Cool. Awesome. So would you say that Grain is an ML?
Yeah, that's definitely a tough question. Whenever whenever folks ask you this, like it's hard. In a sense, yes, definitely. We've got a lot of the pieces that make an ML, right? The type system is like sort of the number one. In fact, I think if you just go from there, it's like, oh yeah, Grain's definitely an ML. But I think in the spirit of MLs, of being languages meant to design other languages, whether it's actually building compilers or just little DSLs and things like that, Grain's not trying to be that. Grain is trying to be more general purpose. So I say it's maybe not an ML in the spirit of being like a proper ML, but for all intents and purposes, the answer is yes, it definitely is.
Okay, cool. And on your website, you say that one of the big goals is to promote wide adoption of academic language features, things that maybe haven't hit the mainstream. What are the most exciting features that haven't reached mainstream in your view?
Yeah, absolutely. So I think the number one, it comes down to type systems, definitely. So we've sort of seen this interesting trend in the JavaScript world of, first, like everyone was pretty happy with just plain JavaScript, not dealing with types, just kind of going all willy-nilly. And now we've seen like the rise of TypeScript being the dominant player here. People really want types. But at the end of the day, TypeScript's type system is fairly strong, but like to like a person who's used a language like OCaml, it feels like it's incredibly weak, right? Like it's not giving you the protection that you really, want out of a type system. And so you start seeing things like this when you have compilers that can tell you, hey, not only did you make a mistake here, but you forgot a whole edge case in your program. And not only did you forget a whole edge case, but here's an example of a case that you missed in your program that you need to handle. Otherwise, you're going to have a bug, and that stuff that has existed in languages like OCaml for decades, right? But it's only just now making its way into modern languages. I think a recent version of Ruby just got pattern matching. There's an ECMAScript proposal for pattern matching in JavaScript. But even, getting pattern matching in there, like they're still not going to have the type system to back it up. So it'll definitely be handy and be great. But I think it kind of goes hand in hand with the type system when you can, enable this sort of like programming, from the future. I think there was actually a really good quote from the folks writing messenger.com. It was written, I think, it's just JavaScript previously, and then they swapped it over to Reason compiled to JavaScript. And they went from 10 bug reports a day to 10 bug reports a year, like something crazy like that. And that's how folks, I believe, should be programming these days, right? Like, let's not, bash our heads against the wall because we got to deal with some, silly type bug in our program.
Cool. And in terms of specific types in Grain, I found the handling of numbers to be interesting and somewhat different from what I'm used to in other languages.
Mhm.
So there's modules specifically to handle specific types of like floating point sizes or whatever, but number itself seems to be very generic or maybe polymorphic, or how would you describe it? What is really going on under the covers there with the number there? And why did you design it that way?
Yeah, absolutely. So our take on numbers in Grain is that for most programmers, they don't necessarily care what the type of the number is. They just really want to say, I have a number, and they want to be able to do things with that number. And especially when it comes around, doing division or things like this, folks like these days we're expecting like something that might happen in Python, right? Like in Python, if you divide 1 by 3, you'll get a third, which might shock some folks, right? The fact that like you've got like these rational numbers, but it's sort of just kind of how math works, right? And that's another thing you don't have to worry about in like these like newer age number systems is the numbers grow. You don't worry about overflow errors or these sorts of things. Like these aren't the sort of bugs that people are expecting. And a lot of times people just want to write programs. Sometimes the numbers get big, and that's okay. It's okay that the numbers are large. They don't care that it's going to take up extra memory or whatever. They just sort of want it to work. And so that's what we wanted the default behavior to be in Grain, where you've got a number, it sort of does what you expect. You can multiply them. They get big. You run out of memory. That's okay. Maybe I'm doing too much with my numbers, that sort of thing. But of course, there are times where you definitely care what the number type is, where it's like, I need to know that, is it a 32-bit number that, and in that case, yeah, let's go ahead and make sure we have modules to deal with numbers specifically of these types. And we try to make sure that those types are very compatible in Grain. So swapping back and forth between Grain's number type and like these other number types is pretty non-trivial. In fact, under the hood, they're actually the same representation. It's nothing crazy going on there. But yeah, the idea is just to have, this one nice cohesive number type that is like, yeah, it's a number, I don't care, versus when you actually do care and just calling out. And that's super obvious in the code too, right? Like when it says this function takes a float, it's like, oh, there's a reason why it takes a float, not just because, I'm restricting you for no reason.
Okay, cool. Thanks for explaining that. And also in terms of Grain types, I find it interesting that they're printable by default.
Mm-hmm.
And I've heard you say otherwise, you like to focus on data first.
Mm-hmm.
So could you explain like how these things work? Why is it printable by default? What do you mean by data first? Things like that.
Yeah, absolutely. So, in terms of, being printable, one of the frustrating things for me back when I was learning OCaml in the beginning was that you can't just print most types. Like you have some data structure and you're doing some debugging, and even though we've got great debugging tools these days, everyone's friend is the print statement or just console.log. Sometimes you just want to take a look at the data and see what it looks like. And that was one thing that was frustrating for me in OCaml. These days, there actually are a couple of tools that, under the covers can actually do some cool printing in OCaml. But in general, one of the things that I thought was necessary for Grain was that we had a nice generic print function where you could print any value and see what it is. So that was something that was fundamental. And so the question was, is it possible for us to do that in a way where even though we might throw away some type information at runtime, can we still print this thing? And we were able to figure out some clever ways to hide the type information away and not have to do anything super crazy there, which was really nice. But it's mostly a developer experience thing. It's like, hey, me as a developer, I've got some data, I want to print it, right? And just not having to go through any hoops to make that sort of thing happen. And it's funny. I think a lot of people who are new to functional programming, they come to Grain and they sort of expect that to be the behavior, and it doesn't shock them. They're like, yeah, I printed it. Okay, whatever. But in like the functional programming world, it actually is kind of a big deal. On the subject of being data first, I think that's what I love most about ML style languages is that you're always thinking about the data. And that's sort of, where the idea behind like enums, comes in, right? Where if I'm dealing with some particular, data, I'm going to list out, hey, these are all the states that this data can be in, or these are all the shapes of this data. And pattern matching feels super natural because you're just thinking like, hey, if the data looks like this, I want to do this to it. If the data looks like this, I want to do that to it, that sort of deal. And so when you start thinking about this way, your programs sort of start to design themselves. It's not a matter of like trying to think of some cool convoluted solution for something. The solutions end up coming to you because you're thinking about the data first. Like, hey, let me design what this data looks like, and then we'll design some functions around that data. And that's a lot of what Grain's about, where in terms of like just building functions and things, you're always thinking about, hey, I'm going to pass data to this and it's going to do something to it. It's not, thinking sort of backwards, like in sort of like an object-oriented style way. You're more thinking about what that data can do for you, which is, pretty neat. But a lot of times it's more about, hey, I've got data and I need to transform it in interesting ways. That's what most of programming is about.
Cool, awesome. And looking more about maybe some of the semantics of the language, it looks like Grain inherits sort of the ML notion of you don't have recursive functions by default. You have to say this is recursive. I also noticed you don't have recursive data types like mutually recursive data types by default. Might this be surprising to some people? And why does Grain apply this kind of feature to looking at how the language works?
Yeah, it's super surprising to some people. But the major reason for that is just we want to help you from just accidentally shooting yourself in the foot, because it's something that happens time and time, again, where they might not mean to, but how many times have you ever been writing a language like JavaScript, for example, and accidentally written a recursive function, right? It's not something that you want to do on accident, to say the least. It's sort of just being very explicit about what's going on, where it's like, hey, I'm writing a recursive function. Instead of making the programmer think about, oh, snap, like this is a recursive function. I didn't realize until I got to the last line. Instead of that, like when you see the definition, you see let rec, and then you immediately know, hey, okay, I got to be on the lookout that there's going to be some recursion that's happening in this function. Or the same thing with, let mute, for example. It's like, hey, I'm going to be mutating this thing later in the program, instead of sort of doing, the reverse of that, of just having everything be mutable by default. Instead, you say everything is actually immutable by default, and then we'll mutate it later. And it's very obvious that I'm going to mutate this thing later, right? Thinking of things like that. But yeah, the idea is just largely not shooting yourself in the foot. And then there's sort of one other usability thing that always feels kind of funny to explain, and definitely shocks a lot of JavaScript developers for sure, is in functional programming, we do a whole lot of shadowing. It's super common to shadow variable names, to say like let foo equal bar, and then let foo equal some sort of using foo again. That's super common. And if it were recursive by default, that wouldn't work at all. And it shocks JavaScript developers because of, like, in JavaScript, the scoping rules for let and const, you can't say let foo twice in the same block. So it's something that definitely catches people a little bit, where they say, what's that? Like, why does that work that way? But once you start using it, it starts to, make a lot more sense. But that's sort of the more technical reason of why, other than the sort of more well thought out reason.
Okay, cool. Now, in terms of possible future features, do you have any plans for like async or coroutines?
Absolutely. It's something that's actually going to be pretty important in WebAssembly. So we haven't necessarily decided exactly what the async story looks like in Grain. It probably will be some form of being able to do generators and being able to resume functions and things like that. However, there are quite a few WebAssembly proposals in flight that are going to be very interesting, which will probably dictate how we end up doing async, where there's like the WebAssembly threads proposal, which is sort of more about having multiple WebAssembly modules operating on the same memory at one time. But I imagine they'll end up expanding it to be able to spawn, threads yourselves. But, being able to do multi-threading, that sort of thing. And then sort of beyond that, yeah, I think we're definitely going to have to see where the WebAssembly proposals take us. I think there's something in the stack switching proposal that's going to be in the cards for us. That's for sure.
Okay, cool. So when do you hope to reach 1.0, and like how much change do you expect from today until then?
Yeah, the mythical 1.0, and when we'll finally make it there. I could honestly see Grain being 1.0 by the end of next year, definitely. I think a lot of what's going to be in Grain 1.0 is kind of dictated again by WebAssembly proposals, where like one of the major proposals is, garbage collection, which hasn't rolled out yet, for fun, which isn't to say Grain doesn't have garbage collection. We wrote a garbage collector, and that's all fine and dandy, but it's much nicer when someone else writes a garbage collector and you get to use it yourself, right? So these sorts of things. But I'd say the number one feature that would be a part of Grain that doesn't exist right now that we need for 1.0 is macros. There's sort of an ongoing joke, either in our Discord or in other channels, where folks will ask macros when. And it's, macros are definitely coming, but I think they're going to be pretty fundamental to how we expect folks to use Grain, over time. So it's definitely going to be a feature that's going to land before 1.0. But other than that, I think, we already have gotten pretty stable code generation, where, folks are already using Grain in production. So Godspeed to those folks. But, even still, we're trying to get more and more stable, get more, features that folks really want, and go from there.
Okay, awesome. So what are your aspirations for Grain? What do you want to see it become in the future?
Yeah, I want to see Grain be the entry point to WebAssembly for a lot of folks. Where right now, folks are hearing about WebAssembly. It's this cool, hip technology. Like, wow, like all the cool folks are doing WebAssembly. But how can I get into it? And then the moment you tell like some folks, like, oh, well, if you want to write WebAssembly, you can go figure out how to configure this compiler tool chain and make it happen. That's super scary for a lot of folks. So I really want to see Grain as the language that just gets folks into WebAssembly, getting more and more, people thinking about WebAssembly, using WebAssembly. If it makes you just try it out and generate a WebAssembly module, then we've sort of succeeded in that regard. But sort of beyond that, I definitely want to see, as we get into a future of, composing WebAssembly modules, like these huge apps out of all these little tiny modules, I want to see people using Grain, like choosing Grain as like, hey, for 90% of my problems, I'm going to use Grain. Maybe I'll choose Rust to write this one, cryptography library, and I won't be offended, by that sort of decision, right? But other than that, like I want folks to feel like, oh wow, this is just so easy to use. I can just knock it out. I'm super productive. Definitely, that's what I want to see for Grain, is just being that go-to language for like I got to get something done.
Very cool. Do you have any other closing words you'd like to share before we're finished?
Yeah, absolutely. It's that, if you haven't checked out WebAssembly at this point, you absolutely should. I definitely think WebAssembly is going to be the future. I've bet my career on it. So even outside of Grain and, my daily work, I work at a company. We're doing all WebAssembly. Unfortunately, open source isn't quite paying the bills just yet, but certainly one day we'll get there. But yeah, definitely, if you're not in the WebAssembly ecosystem, you should definitely go check it out. And definitely, if you're interested in contributing to a project like Grain, you want to come work with me on like some interesting stuff, definitely hop on by the Grain Discord, and we're more than happy to chat and hook you up with some good first issues.
Awesome. Thank you so much for your time today.
Yeah, absolutely. Thank you so much for having me.